This is Mrs. Appia with the answer key for the practice test for Grade 7, Module 5, Topics A and B, Lessons 1 through 9 and 12. The Level 1 questions. Find each probability if you choose one marble at random. How likely is each event? Choose from impossible, not likely, equally likely, likely, or certain. The probability of striped. There are 4 striped out of a total of 8, so our probability is 4 out of 8. In simplest form, that would equal 1/2. The probability of 1/2 is equally likely. The probability of shaded. There are 3 shaded out of 8 marbles, and so the probability is 3/8, and it is unlikely or not likely. The probability of not shaded. Remember that the probability of not an event is 1 minus the probability of the event. So that would be 1 minus the probability of shaded. And we figured out the probability for shaded in the previous problem, which was 3/8. So 1 minus 3/8 will give us our answer. The probability of not shaded is 5/8. There are 5 marbles that are not shaded. And the likelihood of that happening? It is likely because it is more than half. And finally, the probability of white. Since there are 0 out of 8 marbles that are white, the probability is 0. The probability of 0 is described as impossible. The level 2 questions on the test will have to do with the tree diagram. And this is going to show the outcomes for choosing shoes and socks. We'll call stage 1 shoes, and we'll use the symbols A for athletic shoes and O for other shoes. We'll call stage 2 socks, and we'll use the symbol C for colored socks, P for patterned socks, and W for white socks. Remember to list all of your different outcomes. Recall that the purpose of a tree diagram is to organize your data and see the different outcomes that are possible. So we have stage 1, and this is going to represent our shoes. And then we'll have stage 2, which is going to represent our socks. Finally, we will have a list of outcomes. There are 2 types of shoes that we are choosing from. You can either wear athletic or other. Once you've selected your shoes, you select a pair of socks. There are 3 kinds of socks, so you'll have 3 branches, 1 for each kind of sock. So you can wear athletic with colored socks, athletic shoes with patterned socks, or athletic shoes with white socks. Similarly, you might choose other shoes. If you have other shoes, you could have colored socks, or other shoes with patterned socks, or other shoes with white socks. So our outcomes are athletic with colored socks, athletic with patterned socks, athletic with white socks. And those are all of the outcomes if you're wearing athletic shoes. The outcomes if you're wearing other shoes are other shoes and colored socks, other shoes with patterned socks, other shoes with white socks. The probability of selecting athletic shoes is 0.6, and other shoes is 0.4. The probability of selecting colored socks is 0.5, patterned socks is 0.25, and white socks is 0.25. Find the probability for each outcome on the tree diagram. Write the probability next to the outcome above. Okay, athletic is 0.6, so we'll have for this first outcome, we'll have 0.6, and colored socks is 0.5. Then we have athletic again, and patterned socks is 0.25, and athletic socks again, and white socks is also 0.25. So again, our athletic, the probability was 0.6. The others have a probability of 0.4. Notice that these two numbers add up to 1 because they are your only two choices. Then for our socks, we have 0.4, and we'll use that for all of these because they are all having other shoes. And then the socks, the probability for colored socks was 0.5. The probability for patterned is 0.25, and the probability for white is 0.25. To find the probability that you have those outcomes, you multiply those numbers. This gives us 0.3, 0.15, 0.15, and then for the other shoes, we have 0.2, 0.2, or rather 0.1, and 0.1. If you add all of these together, what do you think you would get? You should get 1. Similarly, if you add the probabilities for the socks, for example, we have 0.5 for the colored socks, 0.25 for the patterned, and 0.25 for the white. If you add these together, you should also get 1 because there are only 3 outcomes and they should add to 1. We're down to the final question. Determine the probability of choosing to wear athletic shoes with patterned socks or athletic shoes with colored socks. And show your work. So the athletic shoes with patterned socks, that would be AP, and the probability for AP was 0.15. The probability for athletic with colored socks is AC, and AC had a probability of 0.3. The probability that you choose one of them or the other is the sum of those individual probabilities. And so we add 0.3 to 0.15 to get our answer, which is 0.45. The level 3 questions have to do with estimating probability. What are the possible outcomes for rolling a number cube? A number cube has 6 numbers: 1, 2, 3, 4, 5, 6. Remember that the possible outcomes are what could happen. The probability of rolling a 5. Since there is 1 5 and 6 numbers, the probability is 1 out of 6. The probability of rolling a 2 or a 3. So you would count the 2 and the 3. So there are 2 ways to be successful, and that would be 2 out of 6. And if you simplify that, it would equal 1/3. This is from lesson 6, in case you wanted to go back and watch that video. Beth rolls a die 30 times and records her results. Here are the results from the tosses. She rolls once and gets a 2 on the dice. She rolls twice, she gets a 5. She rolls a 3rd time and gets a 6. She rolls a 4th time and gets a 1. So the top number is how many rolls, and you can see that she's gone all the way and done 30 rolls. And the lower row is the result, and those are all of the numbers 1 through 6 at various spots. Question 9. Fill in the table to determine the relative frequency of rolling a 5. The number of tosses is 1. When there is 1 toss, the result was a 2. So there are 0 5s so far. The relative frequency is 0 out of 1 toss, and 0 divided by 1 equals 0. For 5 tosses, you can see that there was 1 5. 1 out of 5, and 1 divided by 5 is 0.2 out of 10. So we're going over here now, and we've got, I'm going to erase this and I'm going to highlight my 5s. So we add a 5 here, and then we have another one here, and I'm just going to go ahead and get all of them ready. I also noticed that I'm going to be asked to do the number of tosses on multiples of 5. So I'm going to draw a line after every multiple of 5. All right, so now I'm going up to 10. So that would include those 2 5s. There are 2 out of 10 tosses, and 2 divided by 10 is 0.2. After 15, there is one more. Now I have 3. 3 5s out of 15 tosses. And 3 divided by 5, or rather 3 divided by 15 is 0.2. Out of 20, I have 2 more, so now I have 5. 5 out of 20 tosses. 5 out of 20 is 1/4, and 1/4 is 0.25. Up to 25, so I have one more 5. 5 out of 25 is 1/5. Oh, let's go back and fix that. That would be 6. 6 tosses. So I have 1, 2, 3, 4, 5, 6. 6 5s out of 25 tosses. And 6 divided by 25 is 0.24. Finally, at the end of the experiment, there have been 30 tosses. I have 6 5s altogether, and 6 out of 30 tosses, 6 divided by 30 is 0.2. Question 10. Based on the relative frequencies, what would you estimate the probability of rolling a 5 to be? Now remember the relative frequencies, that is from our experiment, and you will find that answer in the last row of your experiment. So the estimate of the probability of rolling a 5 is 0.2, or 1/5. Number 11. Compare your estimated probability to the theoretical probability from number 7. The estimated probability is from the experiment, and that one is 0.2. The theoretical probability from number 7. That's what you expect to happen based on the numbers on the dice. So number 7, the probability of rolling a 5, and again this is the theoretical probability, it's what you expect to happen. That was equal to 1/6. In order to compare them, I would like them to both be decimals. So I'm going to convert 1/6 to a decimal. 1 divided by 6 is 0.16 repeating. I'm going to round that to the nearest hundredth and estimate that to be approximately 0.17. In order to compare these, I'm going to change the estimated probability of 0.2 to the nearest hundredth as well, so that I have 2 decimal places in each number. So that would be 0.20. So comparing my estimated probability to the theoretical probability, I have 20 hundredths and 17 hundredths. Those probabilities are very close together. The theoretical of 0.17 is close to the estimated 0.2. When the estimate approaches or is close to the theoretical, that is a good indication that it is a fair number cube. Remember, when you do the actual experiment, the more you do the experiment, the closer the estimated probability will approach the theoretical probability. And 17 is close to 20. So you do need to explain to get full credit for this. I think it's a fair number cube because the estimated probability from the experiment is close to the theoretical probability, which is based on the number of outcomes. Pause the video and copy the explanation. Question 12. If you rolled a number cube 120 times, based on your estimated probability from number 10, how many 5s would you expect to roll? Show your thinking and write your answer in a full sentence. Okay, we're going to roll the number cube 120 times, and we want to base it on our estimated probability from number 10. The estimated probability from number 10 was 0.2, or 1/5. So 1 out of 5, was that? 1 out of 5 is equal to how many out of 120? That's one of the ways that you can solve the problem. The other way is to multiply your estimated probability times the number of rolls, and you will get the same answer. If you're using a proportion, we will do 120 divided by 5 times 1, and that will give us our answer. I would expect 5 to appear 24 times out of 120 rolls. Remember for the level 4 questions that you need to be able to explain, show your work using mathematical vocabulary.